Now, first one is we want to determine the reaction enthalpy. Follow me closely here. It's a kind of classic. From formation enthalpy, information given. So you look at it, this question, they ask you to find the delta HR of this reaction, right? That's the question. When you're given what? You're given the formation enthalpy. Can you see? What? Who is being given? This is given, right? Let me highlight for you. Who is being given? This is given. Formation of this. This is given. This is given. Okay? But this is not given. Can someone tell me like that how? You should know by now. What is the value? It's always 0 because it's a free element. We talked about this before. All right? They won't tell you about 0, 1. So all these things you must know. These are the basics. This was covered last week. Okay? So basically, you have everything. One indirectly hiding the orange color. Right? So here we go. Let's prove that we got plus 15. Now, the long cut way, there's shortcut lah. But if they ask you to show your working clearly, all right, you have to do this. So again, this type out is very easy, but we want to take a look. What is it? All right. So here we go. Now, what was the first step we mentioned? First step is write out. So in this case, go copy out the equation. Everyone okay? All right, copy it out, and then this is what you want to find. All right, be very clear. This is your question mark. And what are you given? You're given formation enthalpy, the value. So formation is about what? It's about I want to form 1 mole of this, 2 moles of this, 1 mole of this, and 2 moles of this. These are the products that need to be formed. Make sense? By definition, formation enthalpy is based on constituent elements. So I'm going to make it colorful. Usually, you got 2 sides. Up to you. All right, you can attack this side first, try to balance it. All right, then or you try this side. Usually, we do one side, the other side is automatic balance. You can don't check, but I will check because it's just verifying. Right? So here we go. Ask yourself, tin come from where? These are all your standard physical states. Remember, most stable physical states. Tin is a metal, it's a solid. Oxygen come from where? Oxygen come from oxygen gas. Nothing to discuss. Carbon come from where? Carbon come from graphite. Carbon solid. The oxygen, once again, we have discussed it. It's a pink color. So your job is to first take a look over here. You have your constituent element come out, right? This value here and this value here cannot touch, correct? Because it's part of the equation and it's based on 1 mole, 2 mole. So your job is to play with this value here. 1, 2, 3. Which I realize if I do 1, 2, 2, I balance this side already. Am I okay? So your job is to make sure this side is balanced. By doing the orange color. I think it looks good. State symbols must be all in and must be correct. Once it's balanced, usually the other side also the same. You can don't check. But if not, you can check one more time. It's usually fine. Am I okay? So I'll let you take care of it. Assuming it's balanced. Okay? So consider that. Next is, I think step 4, right? They say be careful of the coefficient, right? So here we go. If I use color to show you again. Right? This SNO2 is 1 mole, right? So is what is formation 1 mole. This carbon dioxide is carbon monoxide is 2 moles. So make sure here times 2. And on this side is formation of tin is 1 mole. All right, so formation of tin, which we know the value is 0. And this side is 2 moles of CO2. 2 moles of CO2. Okay? Then what do? We do vector sum. Correct? This thing called red color by Hess law need to write his or her name down. I think it's a he. This is equal to this direction. And I'm going to mix up the color. I'm running out of colors. This green. All right, take a look. It's always here before you go there. Correct? So it's addition. So when the arrow clash with your direction of the arrow, you will then put a negative sign in front to flip it around and add to the other one. Check out direction, same or not? Same, just add. Don't need to put negative. You clean it up, it should give you positive 50. Okay? How long will this take you? I don't think it can go very fast. It will take me at least 3 minutes, 2 to 3. I think 2 minutes probably. Because need to balance it, I need to be careful. I think it will take about 2 minutes. If it's MCQ, do you have 2 minutes? You don't, right? Because MCQ maximum per question is 2 minutes. You can't, because you need to have time to do checking and other question that is difficult. So there's a shortcut, right? Which in case no one introduced to you, you can use. Even structured question can use. If they never say explain your answer or explain your show your working, right? Which is here. This is extremely useful for the MCQ with a calculator without writing anything down. All right. You can solve this within 10 seconds, but you must be very comfortable that you're aware that it can be used and why you should use it. It's a shortcut. So the above one, if you see enthalpy change of reaction, I'm going to use the formation enthalpy information for all the products minus the formation enthalpy of all the reactants. The formula is subtraction. Product minus reactant. And if you look at it, these were all your products just now that you are subtracting off. And these are all the reactants information you have, which gets you the same value. So this equation, is it out of nowhere born out one? No, it's not. It's based on simple observation. Why? Because if you look at what we drew just now using the energy cycle, the simple triangle, it's always, all right, you look at it. I believe it's always product minus reactant. You don't believe, we take a look together. You see, huh? Go back there. Do you realize to do this? I forgot what color I used already. We are coming down here and then we are going back here. Yes, everyone? Can you see this same direction? So it's always positive. Can you see this is the products? Can you see that this side is the reactant, but we reverse it and we always put a negative in front? Can you see? So it's like minus reactants. Are you with me? So put them together, isn't it product minus reactant? Done. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.